Hello and welcome to Maths on the Move, the podcast from plus.maths.org. We speak to researchers from the frontiers of mathematical science so you can connect with the maths that shapes and explains our world. One of our key partners is the Isaac Newton Institute for Mathematical Sciences, next door to us here in Cambridge. Today we're bringing you one of the podcasts we produced as part of that collaboration. We hope you enjoy listening.
Hello and welcome to Living Proof, the joint podcast from the Isaac Newton Institute for Mathematical Sciences and plus.maths.org. I'm Marianne Freiberger.
And I'm Rachel Thomas. Marianne, do you remember back in the early 2000s, there was this incredible news about a proof of the Poincare conjecture?
Yeah, I'm old enough to remember that, and that was arguably one of the biggest mathematical results since the proof of Fermat's last theorem. And we won't go into the details about this result in this podcast. We'll post some links to more information in the episode notes. But for a brief overview, essentially, Poincaré's conjecture from 1904 provides an exact way of describing a higher dimensional sphere. The proof, particular for three-dimensional spheres living in four-dimensional space, eluded mathematicians for nearly a century until the Russian mathematician Grigory Perelman posted his proof in a series of papers on a website called the ArXiv in 2002 and 2003.
So the proof of the conjecture came as a huge surprise to the mathematics community when Perelman posted that paper. People had been trying to prove it and thinking they'd proved it for many years. And it was such a challenging problem that it was actually included as one of the Clay Millennium problems. But what was also surprising was that Perelman posted his work to this website, ArXiv.org. Now, ArXiv is spelled A-R capital Xiv, where the X stands for chi, the Greek letter. And as we'll hear in this podcast, ArXiv is a really important part of the scientific and mathematical community. It's a place where you can post papers early before they've been submitted and peer-reviewed by a mathematical or scientific journal, which is the traditional way that research is verified through peer review by a journal. Instead, ArXiv was the only place Perelman's proof has ever been published. He never submitted it to a journal. And in the press release from the Clay Institute, when it awarded Perelman a Millennium Prize for proving the Poincare conjecture, it said it was the first time that work on a problem of such importance was facilitated via a public website.
That episode was just one of many high-profile examples of how important the ArXiv is to scientific and mathematical research. It provides researchers with a way of immediately sharing their results, allowing others to keep up to date with the latest research, while these results then go on to be verified in the usual peer-reviewed way. In this podcast, we'll hear from Ramin Zabih, the executive director of ArXiv and computer science professor at Cornell Tech.
So, Marianne, we both got to meet Ramin when he was visiting the Isaac Newton Institute here in Cambridge as one of the participants for the AI for Maths and Open Science workshop in April this year. I thought it was so interesting to talk to him, and you went to his presentation at the workshop. ArXiv is a really interesting place, partly the role it plays, but also it's kind of like a demonstration of the way science works and evolves.
Yeah, that's right, because particularly in mathematics, perhaps, it can take an awfully long time to have a paper published in a traditional journal when it's been peer-reviewed, which is obviously a really important process. But in the meantime, before a paper is finally published, it's useful for other people to be able to look at it, to spot mistakes, to ask questions. And often papers are revised many times just through interaction with others through the ArXiv.
I mean, as we'll hear in the podcast, I spoke to Ramin after he gave the talk at the workshop, and he sort of gave examples. In computer science, things move so quickly. There's so much discussion of the papers before they're presented at conferences or finally published in journals that often the paper that originally gets submitted. It's actually like the 8th version of it that is the one that people end up working from, because it's had so much discussion and iteration within the community while it's on ArXiv. So Ramin told me about the role of ArXiv in the research community. And also we were interested, because of the workshop he was speaking at, the impact of artificial intelligence on ArXiv, including some really fascinating possibilities for how the website itself could be the subject of research. So I started off by asking Ramin how to describe what ArXiv does and the scale of its work.
So let me begin with the easy question, which is the scale. ArXiv gets about 1,000 papers submitted per day, roughly speaking. It's grown about 20% per year over year. ArXiv is quite old. It started in 1991. And it has an extremely important role in math, physics, and computer science, as well as in other disciplines as well. But those are where the vast majority of ArXiv's papers come in to those three disciplines. If you want to kind of understand the role that ArXiv plays in the community, it's useful to look at a couple of examples. And I'll pick from examples that are close to my own work in computer vision and machine learning. So one example is the DeepSeek paper that was quite high impact when it came out. I forget exactly how many years ago, relatively recently.
That's a recent large language model that came out of China.
That's correct. Yes, that was on the front page of many newspapers. And another example is the technical report on Gemini on Google's LLM. So what's interesting about those two papers is that if they were sent to a conventional journal or conference in their area, the person who was in charge of that publication venue would love to accept them and would probably not be able to because they would say, well, look, this is great. It's high impact. It's interesting, but it doesn't have the kind of core technical contribution that we look for. Now, to be fair to both DeepSeek and Gemini, they actually do have very interesting technical contributions, but that's not really the point of those papers. The point of those papers is to provide a bunch of technical details about sort of how something was done and where an impressive system is described. Now, the thing is that even if those conventional venues were able to accept such a paper, by the time it made it through, it would be conservatively 9 months, and often, depending on the venue, several years. And so they would be instantly way out of date. So ArXiv hosts those papers, and they're examples of sort of cool and interesting papers which would be poorly served by the existing publication process. And that's what sort of ArXiv does. It hosts preprints. To answer more precisely what ArXiv does is that people submit papers. ArXiv does a lightweight review of them. We call it moderation, where what happens is we essentially determine whether a paper would be something that as an expert in the field, as an editor, would send out for review. We don't determine whether it should be accepted or rejected, but is it something that we would send to a reviewer? And then based on that decision, papers are published. It's very rapid. It's generally the case that submissions come in by 2 p.m. and they go out at 8 p.m. It's the vast majority of things. Yes, it's extreme, and it needs to be given the pace at which certain fields of science, in particular, are advancing these days. So that's ArXiv's kind of overall role. Another sort of interesting example is the Transformers paper, which appeared in the main machine learning conference in NeurIPS, but was submitted to ArXiv before it was submitted to NeurIPS. It is often the case that even for famous papers, there will be sort of multiple versions of it, typically with sort of small changes. And ArXiv makes that easy. So when you submit a paper, you have version 1 on ArXiv, then you submit a new version, it's version 2, et cetera, et cetera, et cetera. And what happens then is that people will submit their paper at all stages of the publication process. They'll submit it before it goes for review. They'll submit it during the review process because they realize, oh, wow, we should have had this graph. We should have run this experiment. They'll submit a new version after the reviews come in, after it's been published, et cetera, et cetera. And the consequences of this on areas of science which are rapidly changing is phenomenal. When you go to, for example, a conference in computer vision, where the final versions of the papers that in the meeting in June, the papers that are being presented were finalized in March. but people generally aren't talking about the March versions. If that's way out of date, they're talking about what happened in April and May, and for that matter, the week before in June. And of course, they know what happened because it happened on ArXiv.
I know from your talk you said that there's been a massive increase in the amount of papers that get submitted, and particularly in the amount of papers that get rejected.
Yes.
Partly due to AI-generated papers?
Yes, that is clearly true. I mean, it's hard to get statistics on it. It's sort of anecdata, as it were. But yes, there's quite a bit of reason to believe that, it is clearly true that ArXiv is getting many more poor quality submissions than it used to get, and it's hard to imagine that is not due to LLM assistance. Now, of course, LLM assistance can be perfectly beneficial. A good example of a virtuous use of LLM assistance is for people who are not native English speakers. And for that matter, for those of us who are native speakers, it also helps us, but it has a very large impact on non-native speakers to improve the English of their submissions.
But there are some AI-generated papers that are spurious and need to be filtered out by the system.
That's correct, and that poses a substantial burden on ArXiv. About 10% of papers that are submitted to ArXiv are held for human review. And as more and more of those papers are AI-generated, the workload on the moderators, who we greatly appreciate, if any of you are listening, thank you so much, is becoming unsustainable. And so we need assistance to help that. And there are obvious ways that AI could at least help with stemming that flood. But yes, that is actually one of ArXiv's major challenges at the moment.
So is ArXiv currently working on AI tools to support the moderation process, either internally or with external partners?
Yes, we are in various discussions about ways to do this. The kind of most obvious thing would be to have AI tools that detect AI-generated content, which is a bit of an arms race between the systems that generate AI content and the systems that detect it. Nonetheless, I think that such tools, there are tools out there. We're actively in discussions with them, and such tools would clearly be quite useful for ArXiv. It's challenging to figure out how to actually integrate them into ArXiv's somewhat complicated workflow. You obviously don't want a system that says, okay, if the AI-generated content detector says that with 80% probability it's AI-generated, we just automatically reject it. You don't want to do that. But at the same time, you do want that signal to be useful to preserve moderator effort. So there's lots of complexity here, but we're definitely working on that. In some sense, it's kind of the only solution in town for that problem.
And given it's such an amazing data set, and given that the other audiences that you have to consider in the process, in the community of ArXiv are the authors of the papers and the readers of the papers, are there other ways that AI could help with that?
Oh, absolutely. In terms of helping within ArXiv, ArXiv has a bunch of complicated policies that would be much better served by being done by an LLM under human supervision. In terms of authors, there's quite a bit of opportunity to make the submission process better, to catch errors earlier, to determine, for example, that your paper, which you're telling ArXiv is a paper about computer vision, that every reference you cited is about computer graphics instead, and perhaps you should instead say that it's a computer graphics paper. That's, by the way, a standard way in which a paper submitted to ArXiv gets delayed, because the person who submitted it says it's about one thing, and ArXiv's automatic systems look at it and say, that doesn't seem right.
Categorization error.
Categorization error. So for authors, there's definitely opportunities there. For readers, there's a whole host of opportunities to take ArXiv content and improve it in various ways. You could imagine discussions about ArXiv content. You could imagine personalized versions of ArXiv that tell you, sort of about recent developments in NLP in a manner that understands what you as the reader know about and what you're interested in. And that would, I think, be a substantial step forward. Many of those ideas are being pursued by startups that are kind of using ArXiv content, and ArXiv's job is to get people to disseminate scientific content. So the more use of it, the better in a certain sense. But there are some real advantages to building these such systems within ArXiv, primarily because ArXiv has a lot of internal data that we, by policy decision made by ArXiv's founder, Paul Ginsberg, way back in the beginning of ArXiv, we don't share that information. We don't tell you so ArXiv knows what papers are popular and doesn't share that information because we want to be sort of a neutral party. That decision was an excellent one. But it means that ArXiv actually has internally a lot of information that it does not share. And so if you were to imagine sort of an opt-in personalized version of ArXiv where you get something, where you go to ArXiv and you get something that's for you, then for that, we're not sort of telling you this paper is popular, but we could use that information. We could sort of, or we could even say that paper is popular among people who seem to be coming from .edu addresses or from the UK or whatever. So there's a lot of opportunity to do better by having such systems within ArXiv than building them just on top of ArXiv.
So one of the most amazing things that Ramin told me about is, so obviously AI generated content is a challenge for the ArXiv, but also there's a role for AI in assisting moderators, authors, and readers. But also there's this amazing opportunity to look at ArXiv itself as this data set, as a resource for machine learning. And Ramin was saying that for some researchers, they don't have access to large amounts of users in order to conduct empirical studies, say if they're developing a new type of recommendation algorithm. So one of the things that they're looking at doing is offering readers some extra cool features if they opt in to participating in this kind of research.
There are areas of computer science that touch on machine learning which are extremely difficult, if not impossible, to do in academia. And an example is people who are working on better search systems or better recommendation systems, things to recommend. I saw you looked at this paper, maybe you should look at this other paper. For example, if you're a researcher, a computer scientist working in this area, you have an idea for a new algorithm, you can write a paper about it with some theorems, but ideally you want to try it and see if it works. And how do you try it? You might be able to get a few of your students to run on to try it, but you'll never be able to get statistical significance out of that small data set. Whereas ArXiv gets on the order of 500 million web hits per month. It has millions of users, millions of active users. And that's enough traffic that at least it's plausible you could actually get statistical significance. So ArXiv could well be such a resource. We were fortunate enough to get support from the National Science Foundation to look at exactly this issue.
Now, actually, there's another thing about ArXiv that is really, really important, which is that it's free. And as you know, if you're not a member of a university, you don't have access to journals, and they're really, really expensive.
And even some universities don't have access to all journals. I mean, I remember when I first started studying, I was in Australia and we had to request access to certain journals, and it would take like 2 weeks. But one of the things that happened with access to everything online gave this open access, but in particular it's sites like ArXiv that enables researchers to really openly share their work, and we can all stay up to date with it.
Yeah, and that's a really important feature. I mean, there's a whole debate and movement in maths and science about open access to research. So the ArXiv just provides that. It's not peer-reviewed, but at least it's there.
It's got that lightweight review, and then it's got that community discussion. I think that was the thing that really struck me in the conversation with Ramin, is his passion and enthusiasm for the role of ArXiv in the community, and that really that was its fundamental purpose, was supporting and sustaining the community of researchers. Given that how much the situation has changed in the last 4 years since the advent of wide use of large language models, generative AI, what are one or two key things that are most important to you and to the team at ArXiv to preserve?
Yeah, well, that's a great question, and I'll point out two of them that I think are quite important. One is that ArXiv really is a community, and those of us who are running ArXiv, who are involved in running ArXiv, are stewards of a crucial resource for the community. And to a remarkable extent, ArXiv does what the community wants, if we possibly can. So, when someone from the math community comes to me and says, could ArXiv do the following thing? The answer is, well, look, if the math community, as opposed to one mathematician, actually really want ArXiv to do this, and it's within our capabilities, we would certainly try to do it. We are responsive to the community. We are a community. And ArXiv is run by scientists for scientists. That's a great ArXiv slogan, again, attributed to ArXiv's founder, Paul Ginsberg. But that aspect, that community focus of ArXiv, I think is absolutely crucial and really, needs to persist. And then the other thing, somewhat related to the two papers, the DeepSeek and the Gemini Tech Report paper I talked about, is that ArXiv is and hopefully will continue to be a home for papers that are poorly served by the current publication process, but that nonetheless have value. And the fact that those papers found a good home on ArXiv, I think is actually an enormously valuable contribution, and one that I hope will continue into the future.
Thank you very much, Ramin.
Thank you for having me.
That was Ramin Zabih, Executive Director of ArXiv.org. Thanks to him for talking to us while he was visiting the Isaac Newton Institute to speak at their AI for Maths and Open Science workshop.
That's it for this podcast, but we'll put links in the episode notes to more information about some of the topics we have discussed. Thanks for listening today. If you've enjoyed, please do recommend the podcast to a friend or rate and review it wherever you're listening. It really helps people find the podcast. Thanks for listening, and bye for now.
Bye.